Every day across the globe, an astounding 1.6 billion liters of milk is consumed. This milk, produced by millions of dairy cows, provides the essential nutrition we need in the form of fresh milk, cheeses, yogurt, and, of course, milk powder. But how exactly is that liquid milk transformed into powdered milk? How is milk powder made and what goes into the process? In this video, we'll explore the incredible journey of liquid milk from the farm to the powder we find in our kitchens. We'll dive into the science behind milk powder production, the machinery used, and the careful steps taken to ensure the final product is both nutritious and shelf-stable. Along the way, we'll uncover some fascinating facts that show how milk powder is produced in modern-day factories. Before we dive in, don't forget to like, subscribe, and hit the notification bell. Stay tuned to discover the fascinating process behind how milk is turned into powder. Let's get started. Understanding milk powder. Milk powder is simply milk that has had its water content significantly reduced through a dehydration process. This transformation leads to the creation of fine powdered milk particles, making the milk more compact and convenient to store and transport. With the milk's water removed, its shelf life increases as it no longer requires refrigeration, allowing it to be transported worldwide without the need for expensive and cumbersome cooling methods. But how did this process come about? The technique of dehydrating milk to create powder was first developed in 1802 by the French scientist and chemist François-Nicolas Appert. At that time, the primary use of milk powder was for feeding soldiers during wars, as it provided a long-lasting and convenient source of nutrition. Over time, milk powder became more accessible and started to be used in rural areas where fresh milk was harder to come by. In the modern world, milk powder has many uses, from being a staple ingredient in baby formula to a key component in food products like baked goods, soups, and even protein shakes. But what does it take to make it? The U.S. dairy industry, a powerhouse of milk production. In the United States, more than 98 billion liters of milk are produced annually, with an average of 87 liters per person consumed each year. This high milk production is possible because of the efficient dairy industry, which is fueled by approximately 60,000 dairy farms across the country. These farms are home to about 9 million cows, specifically bred for their ability to produce large quantities of milk. To ensure maximum milk output, modern farms have implemented automated milking and feeding systems, reducing the need for human intervention. While a traditional farmer can manually milk an average of 6 cows per hour, advanced milking machines allow the milking of up to 100 cows in the same time frame. These farms are designed to optimize cow comfort, increase productivity, and reduce human labor. The science behind cow care and milk production. On a typical dairy farm, cows are fed a specially designed mixture of hay, grass, and grain that's enriched with the necessary minerals and proteins to keep them healthy and productive. Each cow consumes up to 45 kilograms of food and drinks about 200 liters of water every day. This extensive consumption allows them to produce up to 38 liters of milk per day, 7 days a week. Dairy cows begin producing milk after they give birth, a process that typically starts when the cow is between 15 and 17 months old. After giving birth, the newborn calf nurses for a few days before being moved to a separate area to grow up. Meanwhile, the mother cow continues to produce about 35 liters of milk per day for 10 to 12 months. To ensure the cow's health and productivity, farms have advanced cleaning systems, such as automatic floor cleaning every 24 hours, which prevents cows from walking in their waste and getting sick. Animal welfare is a top priority in dairy farming, and studies have shown that cows that are free from stress and allowed to roam freely produce better milk. High-tech milking systems, cow comfort and efficiency. Cows are not confined to stables but are allowed to roam freely both indoors and outdoors, so they can eat and drink at their own pace. Some farms even provide specialized rollers that allow cows to scratch themselves, improving blood circulation and keeping the animals clean and happy. These practices promote animal well-being, which in turn enhances milk production and quality. Each cow is fitted with an identification tag that emits a unique low-frequency signal. This system helps track individual cows' milking habits and monitors the quality of the milk they produce. The milking process itself has evolved to meet the needs of both the cows and the farmers. Instead of milking cows twice a day, cows are now milked based on their comfort. If they feel pressure in their udders, they can simply walk to the milking parlor whenever they need relief. The milking machine has an essential part called the cup, which works similarly to human hands. Each cup creates suction by pulsating on the cow's udder, gently encouraging the release of milk. The milk is then transferred via vacuum pumps through hoses to a storage tank. Advanced technology allows the machine to check the milk's quality as it's being collected. If the milk is of poor quality, too warm or containing blood, for example, the system automatically discards it, ensuring only the best milk is processed. Milk storage and quality control. Once the milk has been safely collected from the dairy farms, it is immediately transferred to stainless steel storage tanks to maintain its freshness and prevent any risk of bacterial contamination. The use of stainless steel is crucial as it helps to keep the milk in optimal condition by preventing the growth of harmful bacteria that can lead to spoilage. To ensure that the milk stays fresh and safe for processing, it is stored at a refrigerated temperature of around 3 degrees Celsius, which is similar to the temperature inside a typical home refrigerator. This temperature helps preserve the milk's taste, texture, and nutritional value while slowing down the growth of any remaining bacteria. At this stage, the milk undergoes rigorous testing in laboratories to ensure it meets the high-quality standards set by the processing plant. Samples are taken regularly from the storage tanks to test for factors such as fat content, bacterial presence, and overall purity. If the milk passes these inspections, it is deemed suitable for the next stage of processing. Once the milk is approved, it is transferred to one of the 12 massive silos located on the premises. These silos are designed to store large quantities of milk and can hold up to 2.8 million liters of milk each. In total, the silos can accommodate over 33 million liters of milk at any given time. This storage capacity is crucial as it ensures that there is always a steady supply of milk available for processing. The silos are large enough to support the production of up to 20 million bowls of cereal, making them essential for meeting the demands of large-scale milk powder production and ensuring that fresh milk is available for various dairy products. The separation process. Removing fat from milk. The next critical step in milk powder production is separating the solids from the liquid. Raw milk contains fat, proteins, and minerals suspended in the liquid, and one of the first tasks is to remove the excess fat. To do this, milk undergoes a process called centrifugation, where a centrifugal separator spins the milk at high speeds to separate the cream, which is lighter, from the skimmed milk, which is heavier. This process is incredibly efficient, with separators processing up to 22,000 liters of milk per hour. The conical-shaped discs inside the separator rotate at speeds of up to 7,000 revolutions per minute, creating a force that pushes the heavier skimmed milk to the outer edge while the cream collects in the center. Pasteurization. Ensuring milk safety. After the milk has been separated, it undergoes a crucial step known as pasteurization to eliminate harmful bacteria and other microorganisms that could pose health risks. Pasteurization is a process that involves heating the milk to a precise temperature, typically around 72 degrees Celsius, 161 degrees Fahrenheit, for a brief period, usually around 15 seconds. This brief yet effective exposure to heat is sufficient to kill up to 99% of harmful bacteria and pathogens that may be present in the milk, such as Salmonella, E. coli, and Listeria. The primary goal of pasteurization is to ensure that milk is safe for human consumption by significantly reducing the risk of foodborne illnesses. By destroying these harmful microorganisms, pasteurization also extends the shelf life of the milk, preventing it from spoiling prematurely. Once the milk has reached the required temperature and the harmful bacteria have been destroyed, the milk is rapidly cooled down. This cooling process is essential to stop the heating process and preserve the milk's natural taste, texture, and nutritional value. Cooling is typically done using heat exchangers or other cooling systems, which help bring the milk's temperature back down to a safe level quickly, typically to around 4 degrees Celsius. 39 degrees Fahrenheit. This rapid cooling prevents the milk from undergoing any further chemical changes or degradation that could affect its quality. By combining the benefits of pasteurization and rapid cooling, the milk not only becomes safe for consumption, but also retains its freshness and high nutritional quality. The result is a product that is both safe and enjoyable for consumers, with a longer shelf life and preserved flavor and texture. Concentration. The next stage in milk processing involves concentrating the milk by reducing its water content. This crucial step helps increase the concentration of dairy solids, which is essential for creating milk powder. It is typically carried out in a device known as an evaporator. The evaporator uses heat to convert the water in the milk into steam, effectively separating the water from the milk. The evaporator consists of several towers that contain stainless steel tubes. As the milk flows through these tubes, it is surrounded by steam, which boils the milk and causes the water to evaporate. This process causes the milk to thicken and become more concentrated as it moves through the tubes. The evaporator's design ensures that the concentration of the milk increases gradually as it falls through the system. An important feature of this process is the reuse of the steam generated during the evaporation. The steam that is separated from the milk is collected and cycled back into the system, reducing the need for additional energy to produce more steam. This not only cuts down on energy consumption, but also makes the entire process more environmentally friendly, as less energy is wasted. By the time the milk has passed through the evaporator, most of the water content has been removed, leaving behind a thicker, more concentrated liquid. This concentrated milk is then ready for further processing, such as pasteurization or drying, depending on the final product being produced. The evaporator plays a vital role in ensuring that milk powder retains its quality and consistency while minimizing environmental impact. Cooling and packaging. Once the water is successfully evaporated from the milk, the next crucial step is to cool the concentrated milk to prevent the formation of moisture or clumping. If the concentrated milk is not cooled properly, it could lead to the powder becoming sticky or forming lumps, which would compromise its quality. To achieve this, cooling equipment such as heat exchangers or air coolers is employed. These devices quickly lower the temperature of the concentrated milk, stabilizing it and ensuring it maintains the desired consistency needed for powder formation. After the cooling process, the concentrated milk transforms into a fine powder. The milk is then put through a spray drying process where it is exposed to hot air, causing it to dry out into a fine, free-flowing powder. The result is powdered milk with a long shelf life as the water content has been significantly reduced. To preserve the freshness and quality of the powdered milk, it is then packed into airtight, sealed containers. These containers, such as cans, are designed to protect the powder from exposure to moisture and contamination. The packaging ensures that the milk powder retains its flavor, nutritional value, and long-term stability. The sealed containers also prevent any external elements like air or humidity from altering the powder's composition, which could affect its taste and texture. The airtight packaging not only extends the shelf life of milk powder, but also facilitates easier storage and transportation, ensuring that it can be shipped to different locations around the world without risk of spoilage. This careful attention to the cooling, drying, and packaging process is essential in maintaining the high standards of powdered milk for consumers. In total, it takes over 8 liters of freshly milked milk to produce just 1 kilogram of milk powder. From the automated milking systems on modern farms to the high-tech machinery used in factories, the process of turning liquid milk into a fine powder is an intricate, well-oiled operation that requires precision, technology, and care. Milk powder is a versatile product that plays a crucial role in the global food industry. Whether it's for baby formula, cooking ingredients, or nutritional supplements, milk powder offers a long-lasting, convenient alternative to fresh milk. If you found this video interesting and learned something new about the process of milk powder production, be sure to like, share, and subscribe to our channel. Don't forget to activate the notification bell so you never miss an exciting behind-the-scenes look at how everyday products are made. Thanks for watching.